Hi, I'm Steve. Welcome to SSI. Today we're going to be going over thread wires. How to use them, what you can and can't use to hold them with. Just a couple of methods, a couple of easy methods that I really like anyway. I know that you can use Vaseline, I know you can use styrofoam. I'm not a real big fan of those myself. I'm more of, I like the dental bands, the small rubber bands they use on braces. I like using clay. The pitfall to clay is that you can't get it underneath the threads or it will give you a false reading. We're going to use a 3/4 16 Unified National Fine Thread Class 2A to take our measurements with. And you'll see that it comes down to basically personal preference on what people like to use. Before we get started, I'd like to give a big shout out to my good buddy Chasen down in Salisal, Oklahoma. Good kid, he was out here in the shop with me not too long ago. Doing a little work, making a few things on the lathe. Just wanted to say hi. Glad you're watching. First thing we'll go to do is we'll go to the lathe and we'll take a few measurements and we'll talk about how to record the measurements to find pitch diameters according to the machinery's handbook. Here we are at the Atlas 12-inch lathe. I have the screw or fastener chucked up into the chuck just to make it a little easier to hold, and more than likely this is the same procedure you'd use if you were actually doing the measurements. Because I don't know anybody that takes the fastener out to take the measurement while they're still working on the thread. If you do, it sure seems to be a lot of work to get it back in there properly. So there's the micrometer taking the measurement. And the removal of the thread wires. Now I'll use clay to take another measurement. I've already gotten the other measurement written down. In some cases, you can go ahead and rotate it. I mean, if you want to do this, otherwise you have to hold the third wire in place. Since I have a camera in my way, I will just go ahead and do it like this. You can see there's no clay between the wire and the fastener. There, now you can see it. And you want to try to get these lined up right over each other the best you can. Well, it looks a little off, but it's there. I'll take a measurement there. Still get a little bit of that clay on things. And I got the exact same measurement to the number. So when we remove this, one thing you want to make sure is you clean your thread wires off before you store them back in the basket or the package that they come in. Okay, now that we've used the thread wires to take measurements, what does all that mean? Where did we get the wires from? Why did we use the wire size that we did? All the little good things that go in with taking measurements over threaded surfaces. So, as everybody knows, it always comes with this little card. Now, this is a thread wire chart. This is for all US 60-degree V-threads. When you look down these little columns, you'll notice that they all have numbers and threads per inch. We use 16. So we had 16 threads per inch for a 3/4 16 unified national fine. We used a wire size of 40 thousandths of an inch. Now there's also a constant number and an add number also in these little charts. A constant number is what is subtracted from the measurements over the wire to achieve the pitch diameter number that you're actually looking for. So, we got a measurement of 769 thousandths 5/10. So we're going to take away the constant number of 0.06587. So minus 0.06587, that gives us 703 thousandths 6/10. So I can write that down. So armed with the information of 703 thousandths 6/10, we have to go to the machinery's handbook and find our minimum and maximums. Our minimum pitch diameter, that's what we're looking for, is 702 thousandths 9/10. Our maximum pitch diameter is 707 thousandths 9/10. So our 703 thousandths 6/10 that we got, doing our math, falls in that area or that tolerance. So the thread's good. This particular fastener was bought from a local fastener store. Not a hardware store, but an actual store that sells nothing but fasteners. At least we know it's good. I've used a couple of them so far. They seem to fit everything that I use a tap on to fit the screw into, or the bolt, fastener, whatever you want to call it. And it seems to thread in very nicely. So we know that one's okay. But that's using the constant number out of our thread wire chart from our thread wire pack to get our answer. For Acme fasteners, it's a little bit different case. We have to use a little bit different math according to the machinery's handbook to achieve what we're looking for. So next, we'll take a fastener like this. This is Acme threaded rod, just a little piece of it. I've used it for a few little things around here as far as holding nuts to turn them down, things of that nature. So I'll put this in the lathe, chuck it up so I can run some thread wires across it, and we should be able to take a measurement. But first, let's talk a little bit about thread wires in general. These packs are sold with a multitude of different wire sizes in it. Doesn't mean you can just go pick and choose. That little chart that comes with tells you that you can't. But where do they derive these numbers from? They derive them from the machinery's handbook. There's lots of different equations, mathematical standards that they use to come up with these numbers, to put them in these little charts. Now, the wire size for the 3/4 16 covers a couple of different sizes. Looks like 16, 14. So one wire size covers two different pitches of thread. Now we go over to using Acme. Since it is a little bit different thread, we can still use the same thread wires, but they have to be found a different way. The Machinery's Handbook has a few equations to help you find the best wire size, and there's also a chart that tells you the smallest size wire you can use and the largest size wire you can use. When they put these charts together for these little packs of thread wires, they take this into account and choose a wire that fits between those two tolerances to give you a wire that you can use and feel confident about getting an accurate measurement. Now, the wire size I'm going to use here is actually 55 thousandths according to the Machinery's Handbook. So we'll put these on here. And all those naysayers out there, it says you never should use rubber bands to take wire measurements. These rubber bands barely have enough to hold these wires on this particular screw or fastener. Just want to make sure it's in the middle. Looks pretty good. Mainly I like the rubber bands. I don't use clay near as much as I used to. Looks like I still got a little piece of clay wrapped around the anvil there. And one thing I like to do that some people don't care for too much is I like to have the micrometer be able to hold itself up on these smaller fasteners. It just seems like it's more firm. I feel more confident in the measurement I'm taking. Some people might say it's too tight. I don't think so. I've done this a long time and I've always had pretty good luck with it. Okay, I did a little bit of digging while I was off camera there. I come up with a few things. We're talking about best wire size. Now the best wire size, this is for Acme, and it's also for 60-degree V-thread. And there is a little bit of variation in the numbers sometimes, but you'll see this, 0.5 times pitch divided by cosine of half thread angle. Half thread angle, depending on what it is, your half thread angle on a 60-degree V-thread is 30 degrees. 14.5 for a 29-degree Acme thread. So I did the math to find the best wire size. So this 0.5 times 100 divided by that bottom number that you see there. What is it? 0.968147 gives me the answer of 51 thousandths 6/10. Well, I looked in the Machinery's Handbook to make sure I was right. Looked it up. Best wire size they said to use was 51 thousandths 6/10. So I know the math is right there. So the wire size for their minimum and maximum that you can use on Acme screw threads, for the minimum is 48 thousandths 7/10, and the maximum wire size you could use is 65 thousandths. It's a pretty broad spectrum. So we're doing fine using 55 thousandths wires to measure our screw thread. Also in the Machinery's Handbook, you'll find a formula that looks similar to this top one here. Now, measurement over wires plus 0.866025 times pitch, which is the 100 thousandths in the 10 threads per inch, it's 100 thousandths between thread to thread, so that's your pitch, minus 3 wire sizes. So it's 0.055 times 3. Now, if we do this math, so the measurement over our wires was 520 thousandths 5/10 plus 0.866025 times pitch, our pitch was 100 thousandths, minus 3 times our wire size of 55 thousandths, comes up to give us a pitch diameter of 442 thousandths and 1/10. Let's see. So, when I go back and look for the pitch diameters for the Acme screw thread of 1/2 inch tin, my minimum is 430 thousandths 6/10 for its pitch diameter, and its maximum is 445 thousandths 8/10. We are at 442 and 1/10, or we could just call it 442 thousandths. Well inside of our tolerance. Say well inside, more closer to the upper end of our tolerance. That's okay. This was also bought as threaded rod, so it is a manufactured part, so it should be correct. Sometimes you have to measure to find out. So hopefully next time on my show we'll be able to actually do a little bit of machine work and maybe make something, or at least go through a procedure of some type. See how things go. Thanks for watching, and we'll see you next time.